today in section 612, we're going to continue graphing some of those three-dimensional shapes that we've been working on yesterday when we were, looking at our, all right, I just need to stop. I'm going to stop. All right, looking at our x, y, and now our z coordinate, or z plane that makes that three-dimensional. So we're just going to kind of continue with that discussion and kind of, how these guys all look and how to figure out how to graph them and all that good little jazz. So 612 in our CPM textbook. If anything, make sure you're jumping online within the next couple minutes to that book, so that way when we get to being able to graph all of these into our little plotter, then we're all set to go. Sound good? Sounds good. All right. So if we want to graph this guy like three-dimensional, so here's an example of like a three-dimensional equation, right? So you have your x coordinate, or you have your x, your y, and your z. Three variables are going on. So we want to be able to figure out how to graph these, right? So for a moment, we could even have a little open discussion that if we know, we kind of talked a little bit yesterday, like if you plotted, like if we just had that x equals 5, we knew that was going to give us a point. And if we had like 2x plus y equals 5, we knew that was going to give us a line. So we went from a point to a line, and now we're adding that third variable on there. What do you think it's going to look like when we graph it? Anybody got any ideas? Somebody thinks it might be like a curve. Yeah. All right. So keep those thoughts in the back of your head of what that's going to look like when we actually go ahead and put this into our little plotter to plot, right? So yesterday we were even talking about when it came to now that we have, instead of an ordered pair, we have this thing and there's 3 of them. So instead of just an ordered pair, there's 3 of them. So it's just a triple, right? An ordered triple is what we call it, because there's 3 instead of 2, right? And we got talking about these yesterday, about what each one of those represent, right? My 4 represents the x, right? What's my 5 represent? Y. Good job, good job. And that -2 represents z, right? So any other time, if we had like a line and they gave us that x and that y, that point, because that point makes up all of those, that makes up that line. So we're kind of thinking the same thing is going to happen with this x, y, z, this triple pair, that this should be someplace on whatever that makes it as a graph. But we always want to check and see if it's going to. So if we wanted to actually see if this was a point that satisfies that equation, what do you think we're going to do? What are we going to do with that x, y, and z?
If you want to hear, it's very fascinating.
So we
I heard the answer.
Yeah.
Somebody said plug them in.
Plug them in, exactly. Good job. Yeah, you guys gotta speak up. It's like there's just that itty bitty little tiny microphone way up in the front of the classroom. So Mr. Nuxmans always yells at me so then I can hear you guys. So yeah, we're gonna try and plug it in. So if we plug it in, we hope that when we solve it, that it's gonna equal 40, right? So let's try it real quick. You ready? So what am I going to plug in for x? I think I heard somebody say 4, right? Plus 8 times, what am I going to put in for y? 5, yep. 10 times z, what am I going to put in for z? -2. And we're going to hope that that equals 40, right? Or if it does or it doesn't, it doesn't matter. It's going to give us an answer. Either it is a solution or it is not a solution, right? So what do we got going on? 20 plus 40 minus 20 equals 40. And I think we get 40 equals 40, right? So it is a solution. So this point, or this tripled pair, satisfies that equation, right? That three-dimensional equation. Sound good? All right. So we're going to go to that little 3D plotter, aren't we? And I think I can do this from here. We're going to... So we just sat there and talked about, right, number 16, considering that equation, and we just did B where we put in that ordered triple to see if it satisfied that, and it did. So then under letter C, it has that little link for you to go to that 3D plotter. So we're going to click on that 3D plotter, and it should pop up looking like this. Everybody there? Over here on the left, it kind of gives you two different options. This first option, if you just wanted to put in points, you would click this one, and then you can put in that X, Y, and Z, and it'll plot any point that you want to plot. But we didn't have a point, we actually had an equation. So if you click on the second one where it says X, Y, Z equals 1, that's going to give you an equation. And it's going to give you what that graph looks like, right? So this one is just where X plus Y plus Z equals 1, right? It would be kind of like almost think of like that as your parent function of a graph. And what you can do with your touchpad, you can move this baby around and it shows you what it actually looks like, right? So granted, when we made our little model, we only made that one quadrant. So this one, of course, has all 4 quadrants. And as you spin it around, you can see your x-axis, right? You can see your y-axis and your z-axis. So when I plot in 3 dimensions, remember how 1 dimension was a point, 2 dimension was a line? What's 3 dimensions making? What do you think you would call that thing? Starts with a P. Goes in the sky too. A plane. Absolutely. Yep. So when we graph in 3 dimensions, we get a plane. And our plane technically has no thickness to it. I mean, we have to kind of shade it to a color in a sense. No different than a point or a line. A point or a line technically don't have any thickness to them, right? So the same thing happens when it comes to a plane, right? So we actually want to put in that equation that we were just working with. If you click on the actual equation that X plus Y plus Z equals 1, I don't know why, but for what on this program, it changes it to A, B, C, D. X is your A, the letter in front of your coordinate in front of A, or in front of X is A. The number that you want to put, the coefficient you want to put in front of Y is your B. The coefficient you want in front of Z is C. And if you want to change what it equals, that's your D value. So ours was 5x. So you can either click on it and type a 5. Our B was 8, or you can use like the plus to get you up to 8. Our C was 10, and that equaled 40. Okay. And then you guys can kind of spin it around and see that cute little plane. And if you guys can see those yellow, I think yours would be yellow too. There's these little yellow dots. There's one right there, and one right there. And that's actually showing you your intercepts, where it's crossing the x-intercept, where it's crossing the y-intercept, or the y-axis, and where it's crossing the z-axis. So it's giving you your x-intercept, your y-intercept, and your z-intercept. And that's really important for our next problem when it comes to us wanting to plot these. Sound good? Alright. You guys all good on figuring out how to put these guys in? Is that a big, loud yes? Sounds like it. Alright. So we're going to go back to a problem. Oh, I got to move everything. Alrighty. Make it a little bigger for you. Alright. So we always don't have that little plotter in order to be able to graph all of these points or to figure out like where they cross the X, Y, and Z axes. So sometimes we just have to do it by hand algebraically to kind of figure out where these are going to intersect. And this will help like when it comes to like using that that little model that we made. Is after we figure out where it crosses the X, the Y, and the Z axes, then we can kind of like plot those 3 points, and then we can actually like kind of like see the plane in a sense. And I used to always do this little thing in the classroom when it came to actually I'm going to stop sharing this for just a second. Right. When it comes to trying to figure out like those 3 points, when it comes to anything like a plane is any 3 points make a plane. And if you want to find like the most sturdiest structure, I think this might work. Like if you try and take like your fingers, right? Like, and if I try to balance something on one finger, like that's not balanced at all, right? That baby's gonna fall all over the place. And then you can sit there and you can try and do it with 2. And you can usually get it set pretty well to where you can get 2 on there, but it's still pretty wobbly and it's still going to fall over, right? Whoa, there it goes. But the crazy part is if you take 3 points, like my little fingertips are my 3 points, and I put a plane on there, man, it's getting a little bright outside. You know, I need a blind, right? I put those 3 points on that plane, and guess what? That baby ain't going nowhere. All right? So there's this whole thing of like when it comes to a plane, any 3 points make a plane, and no matter, I don't have that many fingers, right? Any 3 points, and whatever I lay on there, that's going to give me a nice little flat structure. So we need 3 points. So really for us, because we just want to be able to do some of this by hand, if I can figure out where it crosses the x-axis, the y-axis, and the z-axis, it gives me those 3 points. And then I got those 3 points, I can make a plane. Then I can go anywhere I want to go, right? Because I have a plane. That was a joke, guys. Whatever. I'm going back to I'm done. I'm going back to sharing my screen. I'm tired of you. Whatever. So, if we think of like in 2 dimensions, this is hard to teach from here, say, like teaching to my kitchen plan, right? When it comes to figuring out those intercepts, when it came to just a line, we would plug in 0 for x, and it would give us our y-intercept. If we put in 0 for y, we could find our x-intercept. So the same thing kind of applies to this when it comes to these 3-dimensional shapes, but we want to be able to figure out our x alone, our y alone, and our z alone. So if I want to figure out where I'm crossing the x-axis, so my x-intercept, I got to make my y equal 0, and I got to make my z equal 0. So I'm going to take my equation. We'll write it out the long way the first time, right? 12x plus 4y plus 5z equals 60. So if I want to figure out my x-intercept, I got to put a 0 in for my y and for my z. So then I'd have 12x plus 4 times 0 plus 5 times 0 equals 60. So I'd have 12x equals 60. To get x all by itself, I would divide by 12, and I would get x equals 5. Good job. So where am I going to cross the x-axis? At 5, right? So then now I need to find my y-intercept. How am I going to find my y-intercept? X is going to equal 0, and z's got to equal 0, right? And then sometimes we can kind of take a little shortcut. If I know x is 0, this is going to go away, right? And I know if z is 0, this guy is going to go away. So I'm left with 4y equals 60. Okay? So 4y equals 60. Y is going to equal
Hold on a second.
Somebody said 15, right?
Yeah, I did.
And then the last one I gotta find is my x-intercept. Whoops. To find my z-intercept. So to figure out my z-intercept, x has got to equal 0 and y has got to equal 0. So I'm going to have what? 5z equals 60. Z is going to equal 12.